Hello everyone. In this video we will continue to examine how to produce your GP practical reports, and in particular we will take a look at your variables tables. So the independent variable, dependent variable, and control variables are all discussed and formatted into a table. In your table, you're going to have one that is dedicated to the independent and dependent variables, and then one that is dedicated to the control variables. So let's first take a look at the independent variable and dependent variable table. Notice you'll have a title, you'll specify that it is the independent variable and the dependent variable, and then you'll put the actual independent variable and unit in sort of that middle box here. Okay, so you're going to say, here's my independent variable with the unit, and then you'll give it, same for the dependent variable. And then in the right-hand box, you're going to explain in a couple sentences how the independent variable is manipulated, changed, and measured. So what is being done to manipulate the independent variable, and how is it being measured? Make sure you specify a list of the values chosen. So for example, if you're changing the height, you're going to give a list of the heights, right? Right here. Each value with units. You'll then spend a couple of sentences and up to a full paragraph to explain and give the estimated uncertainty. So you write down the estimated uncertainty, you say the estimated uncertainty on this value is, and then you explain how they were estimated. Make sure that you use correct reference to both instrumental and/or methodological sources of uncertainty as needed. So however you estimated it, you want to give a brief paragraph justifying your choice of the estimated uncertainty. Remember that that estimated uncertainty should have no more than 2 significant figures. Finally, you're going to do the same kind of thing for the dependent variable, but you don't need to say how the dependent variable is being manipulated or changed. It's presumed that it is being manipulated or changed by the independent variable, because the dependent variable depends on the independent variable. And so for the dependent variable, you just need to explain briefly how it's measured specifically. Okay, so what's the tool that is being used to measure it, and how is that being done? Secondly, you also give a brief paragraph on the origin of your estimated uncertainty for the dependent variable. Okay, just as before. Then you're going to do the control variables table. So the first thing to recognize is that for a given experiment, you should have at least 3 control variables. Some need more, some need less, but basically the idea is that any significant control variable should be something that you speak about. Notice, a control variable is in fact a physical variable. And the very most common mistake here is that people will say, you know, the same ball was used for each measurement. That's not a control variable. That's a method of control. Okay, how are you controlling other variables where you're using the same ball? Equipment is not a variable, all right? So what might you be keeping the same? Well, physical variables of the ball or related to the ball might include things like the mass, the material, the shape, okay? Those are things that are variables. You should at least be comfortable putting a unit on your control variable in order for it to be a variable. And if you know the value of the control variable, it should have a specified value with an estimated uncertainty and correct units. So if you're saying you're keeping the mass of the ball the same, you should have the mass of the ball with an estimated uncertainty. Now, I know that sometimes you don't always have access to the measurements required for this, but if that's the case, you should just specify that. The method of control is almost always super straightforward, okay? It's how you're controlling the variable. It's not always straightforward to do, and it's not always straightforward to have thought of in the first place, but usually writing up is pretty straightforward. You just say what you did to control the relevant control variable. And then finally, for the control variable, you need to fill out this third column, which is one of the trickier parts of the report. All right, and this is really important. This is one of the things to do latest. It's the most subtle. And the idea is that you need to discuss, this is a full discussion, multiple paragraphs, discuss the effect on the data if this variable were uncontrolled. So if it were uncontrolled, what would happen? And you're going to integrate into your discussion accurate use, correct use of systematic and random error, precision and accuracy, and you need to connect the potential effect on the measured variable with any determined quantity, any quantity that you derive later on. So, for example, for the acceleration due to gravity lab, perhaps your control variable is the specified release height, understood as sort of like exactly where the bottom of the ball was. So not the height itself, but exactly the position on the ball where that height might be. And you might say something like, well, if that specific height were uncontrolled, then it could introduce both random and systematic error on the measurements of the times. For example, if the drop height were changed systematically to be higher, then all of the measured times would be longer than expected, okay, and therefore reduce the value of the acceleration due to gravity found. That is a negative systematic error on the final result that would produce inaccuracy. If the drop height were not carefully controlled from trial to trial, then random error could also be introduced into the times measured, as they could be measured to be both longer and shorter than expected, and therefore introduce imprecision in both the times and the final value for the acceleration due to gravity. So this is a challenging paragraph to sort of synthesize, and the big important aspect of this section is to say, what would happen to your data? What would you expect the effect on the data to be, and the effect on the final value of the acceleration due to gravity, or whatever value is being found, if the variable you are discussing is uncontrolled? That's what goes here. And you want to correctly use your terms from our uncertainty and error unit. Notice some students like to put a section on uncontrolled variables. This is super optional. These are just potential variables that will affect the investigation but are impractical to control. You generally should show sort of how you're minimizing or monitoring such variables. But if there are uncontrolled variables that will directly affect the investigation and are impractical to control and would dramatically affect the data, then you probably shouldn't be doing that experiment in the first place. It's not a very well designed experiment. That's why this section tends to be optional.